Hello everyone, so welcome to the session of Digiimento. Today we are going to discuss the left out portion of Algo, and after that we are going to start with TOC today. So I am taking the subjects earlier which have more priority, okay, so that you can revise them quickly and can have better understanding in the subject. And trust me, these classes are very helpful for you all because it is the quick revision which I am doing through formulas, through concept, okay. So let's get started everyone, and let's see the remaining portion of Algo, which was of 10% or let's say 5%, and after that we will start with TOC. Okay, and those who haven't watched the data structure and C programming, so please do watch. It's like a revision classes which you can do just in 1 hour. I have covered the complete data structure C programming, so you can watch and take most advantage of it, because the last time, this is the only 10 to 15 days are remaining, and these are very crucial for revision test series. So just to help you more, I have created this class, okay, and we are taking this class. So if you have any doubt in this class, do ask me in the comments, okay, and I will answer all your doubts. So let's get started with AVL tree. I hope you all can hear me and the class is and the screen is visible. Let me check one time. Yes, you all can see, and I'm audible also. Okay, so let's get started. AVL tree. So here AVL tree is self binary tree, okay, where difference between the height of the left and right subtree of the node should not contain more than 1. Okay, so balance factor of this is balancey factor or balance factor of this can be 0, -1 or +1. Okay, max number of nodes of height h is 2h plus 1 minus 1. Okay, and minimum number of nodes is equals to n of h equals to 1 plus n h minus 2 n minus 1 or h minus 1. Okay, now this was AVL tree. Let's discuss about heap. So heap is a complete binary tree with the property that the values at each node is drawn as long as value of the children. So root greater than modulo of L comma R, which is max heap, and root smaller than L comma R is mean heap. Okay, and max number of node at level I of binary tree is equals to 2i minus 1. Okay, number of level comparisons for node getting inserted at level I is equals to I minus 1. All right, now total number of comparisons max for nodes at level I is equals to I minus 1 into 2i minus 1, right? And here Tn equals to number of comparisons for all nodes at all levels, okay, which is I equals to 1 k, here I minus 1 into 2i minus 1, which is, so the time complexity of this is big O of n log n. I hope you can consider this as big O. Okay, So this is big O, right? And insert in heap equals to big O of log n, all right? And build heap or heapify is big O of n. Alright everyone, so this was all for the algorithm, and the algorithm subject is completely over. I hope there is no doubt, and if you have doubt you can ask that in the comment box or in the live class as well. Okay, so I'm there to help you all. Now let's see the TOC subject. Okay, so TOC subject and CD makes up to 8 to 10 mark every year. Okay, algorithm and data structure, C programming, this comes for 18 to 20 marks. So very important and easy also. If you spend time in practicing these subjects, surely you will get the marks, and that is for TOC and CD as well. Both are very simple, but you need revision for this and practice as well, but they are really very scoring. Okay, so let's get started with this. So now we are going to discuss TOC first. Okay, so TOC, now let's see the basics of TOC. The very first is symbol. What is symbol? Okay, what is symbol? Lowest unit represented, lowest unit represented by lower case or simple symbol. Okay, and these are also known as terminal, also known as terminals. These are also known as terminals. Okay, now let's see strings. So string is nothing but sequence of symbols denoted by W. Okay, strings should be finite and sequence matters. All right, now the third one is length of string, which is denoted like this, W. Okay, so which is number of symbols involved in the string, which is, let's say, W1 is equals to 4, right? And one thing you should understand, that W cannot be infinite. Length of string cannot be infinite. This can never happen, right? Now let's discuss empty string or null string. Fourth one is empty string or null string. And this is denoted as epsilon. Okay everyone, this is denoted as epsilon, and this is nothing but string with length 0. That is W is equals to 0. Alright, and this epsilon is a string, not a symbol. This you should understand. Okay, now the fifth one is concat of strings, which is concatenation of two strings will always be a string. this you should know. So concat of two strings of two strings will always be a string, So w dot w1 dot w, this point you should understand, w1 dot w is not equals to w2 dot w1, okay, but epsilon dot any is equals to any dot epsilon is equals to any. So this equation is you should understand, and from this can we say that this is non-commutative. This is not commutative at all, okay. So let's understand now prefix of a string. So the 6th point is prefix of a string. Prefix of a string. So let's say we have w1, which is a, b, e, d, okay, and this is prefix w1. So what is the prefix of w1? Alpha, after that a, after that a, b, after that a, b, c, right, and then a, b, c, d. Okay, so sequence of leading symbols is called as prefix of a string. And there are some important points, that a string is a prefix of itself, and epsilon is a prefix of every string. Let's similarly discuss for suffix of a string. Suffix of a string. So suffix of a string means w1 equals to a, b, c, d. So prefix you all, now this is the same string. So what will be the suffix? So suffix will be epsilon, d, c, d, b, c, d, and a, b, c, d. This one. Okay, so the sequence of tailing symbols. And again the same points are repeated, that a string is suffix of itself. Here prefix is there. I am going to copy the same point. Just going to update here. Okay, in terms of prefix, here should be suffix. Here should be suffix. Now let's understand what is a substring. Okay. 8th is, so I hope there is no doubt till now. If you have any doubt, you can ask. Any doubt till now? You can ask, you all can ask. Okay, so let's move ahead. 8th is, what is substring? So these are very simple basics, but generally the aspirants don't know this also, and they get confused in the PYQs while solving. So these concepts are very important if you are starting with TOC, and we are doing the whole revision of the subject. Okay, so please pay attention to the complete lecture, and it's just of 1 hour. Okay, so you can easily do it. So substring, it is a string present in the string. It is the string present in the string. Let's say W is A, B, C, D. So what are the substrings? Substrings are epsilon is there, A is there, AB is there, ABC is there, ABCD is there. Okay, and this is called as C. This is called as trivial. Okay, and this is also called as, this W is also called as trivial, right? After that, what can be the substring? So here B can be there, BC can be there, B, C, D can be there. After that C can be there. C, D can be there. After that D can be there. So these are all the substrings. So if W is n, then max number of substring is equals to n into n plus 1 by 2 plus 1. Okay. So this is the thing, and this plus 1 is for the epsilon. Alright. So this is nothing but summation of n plus 1. And I am going to tell you all that this is valid when all symbols are unique. That means distinct. Okay, this is then applicable. Now let's see reverse of a string. Point number 9, reverse of string, which is WR, reverse of string. So here W is equals to A, B, C, D. So what should be WR? This should be C, D, B, A. Okay. So W, WR and WR, W, these are like palindrome. You all know what is palindrome? If you will reverse the name, it will be as it is the same. That is palindrome. And let's say W is epsilon. So WR will be what? Epsilon. Okay. So like this, it is the case. Now let's see the 10th. What is language? Okay, everyone. Language means set of strings may be finite or infinite. May be finite or infinite. Okay. Now here empty language is possible, like L, this is the braces, which is equals to phi, which is equals to, but you have to remember phi is not equals to phi inside the set. This is not empty language. You all should know this is not empty language. Getting everyone? This is empty language, this is empty language, but this is not empty language, because in the set we have phi. I hope there is absolutely no doubt in this. Okay, very, very important point. Now let's see the next one. Now let's see what are alphabets. Okay, 11th is alphabet. So alphabet is denoted like this. Okay, so alphabet is generally non-empty finite set of symbols on which the language is defined. I will give you example also. The language is defined. The language is defined. So here the point we should note that with alphabet language is not possible. So the point you should note without alphabet language is not possible. Okay, and infinite alphabet not possible. That is why I have written that finite number of alphabet so that it can create a language, right? So for L, this is this, and language, this is epsilon. Any alphabet is valid. For this language, any alphabet is valid, and this does not contain, alphabet does not contain epsilon. Alphabet does not contain epsilon. This you should know. Okay. Now let's understand what is power of strings. Twelfth is power of string. So what is power of string? Wn. So n belongs to z plus, okay, which means a positive number, right? If w is equals to abc, then what is w0? So this is epsilon. What is w1? So it is w. It is nothing but w. So it is abc. Now what is w2? So this is w into w. That means it is abc dot abc, like this. If you write w3, so what this means? W concatenation with w concatenation with w. So it will be exactly equals to abc dot abc dot abc, right? Okay. Now let's see concatenation of a language. So the 13th is concat of language. So it's just like Cartesian of two sets. Let's say if L1 is equals to a comma b and L2 is equals to 1 comma 2, then concatenation of language is finite only if both of them are finite. So very important note which I am writing, concat of two language is finite only if both of them are finite. Both of them are finite. So it will be L1 dot L2, so which is A1, A2, B1, B2, like this. So this will be the case. And if any of the language is concatenation is like finite, then the concatenation is finite. So this is also the important point. Okay, I am writing if any of the language in the concat is infinite, then concat is infinite. Then concat is infinite. Okay, and so the one thing which you should note is phi. Okay, this is a very different color. So phi dot any is equals to any dot phi is equals to phi. The result is this. Okay, now let's concentrate on reverse of a language. So the 14th is reverse of a language. So till the time, let me see that if anyone have any doubt. No doubts, everyone? Okay, so let's move ahead. Reverse of a language. Reverse of a language means LR. This is how we denote reverse of a language. So LR contains WR for all W belongs to L dot L. So it is equals to AB, BA, AA, BB, AB, like this. What will be then? What will be LR? So it will be BA, it will be AB, it will be AA, it will be BB, it will be AB, like this. So this will be LR. Okay, now let's understand 15th point, which is power of language. Power of language. So which is Ln, where n belongs to z plus. Okay, so L is a comma b, then L0 is epsilon, L1 is L, which is a comma b, L2 is L dot L, which is AB and AB, like this. So the concatenation of this is AA, AB, BA, BB, like this. Right, everyone? Now 16 point is union and intersection of two language will always be a language. Now, so this is note. Okay, now let's talk about 16th point. Let's discuss complement of a language. So complement of a language, which is LC. Okay, so LC is universal minus L. So universal minus L will give you L complement. So if you do universal complement, it will be phi, and if you do phi complement, it will be universal. Like this it is. Now let's discuss set difference. Set difference is L1 minus L2, which is L1 intersection L2 complement. Okay, like this. Let's discuss about clean closure now. 18, clean closure. So clean closure is like a star. Okay, so A star means what? U infinite. Okay, so it's A star. Just remember this. It is A star, and what A star means, that it is A0 union A1 union A2 so on till infinity. So which is epsilon A and so on. And this gives a long infinite output. Okay, now A plus B clean closure. So this is all combinations on A and B. Okay, so it is universal language for AB, right? And this is very important, is that epsilon, this phi clean closure is epsilon, like this, set of epsilon, very very important. After that, A star B star, like clean closure, so A plus B star. Okay, this is first point. Second is A star plus B star is A, all strings of A. After that, all strings of B and epsilon. But it is not like AB, such things will not happen in this. After that, A closure A, this is equals to A star. Okay, so I hope clean closure is absolutely clear. Now let's see 19th, which is positive closure. So positive closure is plus, and A plus means, okay, A plus means epsilon is not there, but it will be A till infinite. Here the difference is epsilon is not there. So A star is nothing but A plus epsilon, and A plus is nothing but A star minus epsilon, and A star is nothing but A plus. These are the properties which you should remember. And phi plus is nothing but phi, and A plus, this plus is nothing but A plus. Okay, and this A star B star plus is nothing but A plus B star. Okay everyone? Okay, so this is nothing but epsilon, this is nothing but like this. Okay, see, because if this is phi we made, and phi plus phi is phi, so phi is generated. After that, any kind of A and B we can generate. We can generate BA also from this. Let's say I have taken like this. So I want to generate BA. So this will be phi, this will be B. After that, this A will be there from here and this will be phi. So this is generating. So it is generating complete language, right? So that is how you all can check. Now let's discuss regular language. So this was the basic which I have covered of TOC. Now let's discuss the regular language completely. And I hope that there is no doubt in the basics of TOC. And trust me, this is one of the most coring subject with CD. So you definitely should not skip. At least you should have these basic knowledge. Okay. Now let's cover all the regular language. So now the topic is regular language. Regular. And we are going topic wise topic. Alright. So that there should not be any confusion. And let's cover everything. So regular language means, let's note some point. So regular language means language is regular. Let's write the point. Language is regular. And if language is regular, that means it is accepted by finite state machine. So if accepted by finite state machine. And what is finite state machine? This is DFA, NFA, epsilon, NFA. That means if a language is accepted by any of this automata, then the language is a regular language. Okay. Now let's discuss what is finite state machine. So finite state machine. Finite state machine is nothing but FA. And this is finite state machine or finite state automata also we can say. So this is FA. So it's nothing but Q0 initial state. After that alphabet. After that states and final state. And this is the transaction. Okay, like this it is there. And this is nothing but the definition of finite state machine. Okay, so for DFA it's like Q into this is like Q. So this is for DFA. This is Q into alphabet. So this is 2 to the power Q. And this is D Q into this alphabet epsilon, which is 2 to the power Q. So these are nothing but, this is DFA, this is NFA, this is epsilon NFA, epsilon NFA. Okay, and FMS, okay, may, and what is FMS? This one, finite state machine. So a FMS can have 0 or more final state, but exactly one initial state. Alright, now let's note some very important points which you definitely should know if you are learning regular language. Okay. Yes, so let's see one by one the statement. First statement is if language contains epsilon, then initial state will be final state. Initial state will call as final state if language contains epsilon. Second is if initial state is final, okay, then language contains epsilon. Okay. Third is a language may have more than one finite state machine for it, but but the transaction of FMS is always unique. Okay, a language may have more than one finite state for it, but FMS is always unique. Okay, and if you don't understand this point, so let it be, right? Let it be this point. Now let's see the next point. Finite language is always regular. It's always regular. And C, for finite state machine, for finite language will always have a dead state. This point is very important. Finite state machine, or let's say finite automata, FA. FA is finite automata, or I have written, and FMS, finite state machine, is the same. Okay, for finite language will always have trap state or dead state, anything you can say. Let's say I have to make the finite meta of AB. So how I will make? Like this, AB. But now here B transaction should also be there. After that, this should have A transaction. This should have both AB transaction, and this is the dead state where A and B will be there. So that is why this is finite, AB is finite, so it will have a trap state or dead state. Okay, so the points I think which needs explanation I am giving. Otherwise I am simply writing the points because they are very simple. Okay, so this is clear. Fifth one is finite language FMS will never have loop. Okay. Sixth is if we make all states final in DFA, then it accepts a complete language. It is called as it is accepting a complete language. So this symbol states that complete language. Okay. Now let's note the next point. Seventh is by finite automata we cannot do comparison or counting as it has no memory. Okay, it has no memory. So it means that memory in forms of state. It has memory, it has only memory in forms of state. So that is why any type of comparison counting we cannot do, right? Eighth is linear power of symbol is always, so actually this is power of symbol is always regular. Is regular always, I am writing like this, is regular always. Alright. Then ninth is mod machine are always regular. Mod machines are always regular. What is mod machines? Mod 3A, like this. Okay, so like this are always regular because they have finite number of states. So mod of 3 will be, how many states we will have? 0, 1, 2. So this is definitely a finite. Okay, so that is they are always regular. The 10th point is non-linear power of symbol is non-regular language. Non-regular language. L means language. Okay. And 11th is dead state or trap state, not required in NFA or epsilon NFA. It's only there in DFA. Okay. And if we discuss the power, so power of DFA is same as NFA and is same as epsilon NFA. Okay. So it's like we are converting epsilon NFA to NFA and we are converting NFA to DFA. Okay. Now if you will ask question that why we cannot convert DFA to NFA, because if you are good, okay, if you are getting good, after that you are getting best, so again will you turn to good? So this is good, this is best. So you have turned from good to best. So are you again going to do the reverse, best to good? Will you degrade yourself? Definitely not. So this is good, better, best. So it's like good, NFA is better, DFA is best. So why it will degrade itself? Okay, so that is why the conversion is not there for DFA to NFA. It's from epsilon NFA to NFA, NFA to DFA. It's like this. Okay, and the powers are always same. 1 mark question can come from here. Power same means we can convert them into the language each other. Okay, now let's note the next point. 12th point is that dead state can never be final state, and in DFA at most one trap state or dead state is there. At most one, that means it can be 0, no dead state, it will be 1, but not more than that. Okay. 13th is if we make all state as final in NFA, then it will accept prefix L. That means language containing all prefixes of all language is string. Okay. Now let's see the complement of finite state machine. So complement, let's see this in the next page. Okay. Now let's see this. Complement of FMS. So which is like this. Okay. So change from final to non-final, and the change from non-final to final. And one thing you should note from here is that this is only valid for DFAs and invalid for NFA. So this is only valid for DFAs and invalid for NFA. Okay. And do not reverse the arrow. So the arrow should not be reversed. Okay. The complement of a regular language, is always regular. Okay. And the concat of two language is always, the concat of two language is always regular. Okay. Now let's see the reverse of a machine. Reverse of a machine. Reverse of a machine is MR, like this. Okay, so reverse of a machine means what you have to do basically in this, make initial state as final state and all final state has as non-final arrow. Okay, as non-final as initial, and after that we have to reverse the arrows. Okay, like this you will easily do the reverse of a machine. Then reverse of DFA could be NFA. Reverse of regular language is always, so RL is regular language, is always regular language. Okay, if more than one initial state we have after conversion, then make new initial state with epsilon transition to them. Okay, that means if this is also initial, this is also initial, so the epsilon transition, and this will be the one initial state, like this. Okay, so it will be like this. So from epsilon transition you can make as one initial state. So there are various examples, okay, of comparisons. Now you all have studied about the standard is smaller than equals to, so n is smaller than equals to 10 to the power 7. Tell me whether this is regular or not. So just master this question, and 8 to the power p and p is prime. So tell us, and where p is smaller than equals to 30. So tell me whether, okay, this is regular or not. So just practice these kind of questions. There are high possibility to indicate that such questions can come. All right. So let's see now the next topic, which is regular expression. Regular expression. So regular expression means mathematical formula used to present regular language only, right? And the first one is if regular expression, this is RE, this if regular expression for a language exists, then it's regular language, then it's a regular language. And if regular expression for a given language will generate only the strings in the given language, okay. Now let's see, in the regular expression also there are restricted and semi-restricted symbols, and some restricted are also there. So RE is there, it is divided into 3 categories, whereas unrestricted, semi-restricted and restricted. So like this, and this will be having alphabet, after that this concatenation, closure, plus like this. So actually this is out of syllabus, okay, let's not discuss this. This is out of syllabus. There is no meaning of discussing this. I thought too, but let's see. Okay, but what's in the syllabus? So RE, which is restricted. Let's learn this, restricted. So unrestricted and semi-restricted are not there in the syllabus. Restricted is there. So let me explain that. Restricted, So this will be like this. Okay, concatenation, closure, plus, union, intersection, all this. And you know what is the priority to uh, solve this? First bracket you have to solve, after that clean closure, after that positive, then concatenation, and then plus. So this is the order of evaluation. Order of evaluation. Okay. Now let's understand what is Erdős theorem. Erdős theorem. And one thing you should note that only for epsilon free finite state machine this is for. Okay. So the expression for this is R equals to Q RP, R equals to Q P star, like this. Okay. So here R, Q, P are regular expression where Q is not equals to epsilon, and it has unique solution where R is equals to QP star. Okay. Now let's discuss some algebraic laws of regular expression. Algebraic laws of regular expression. So the first is commutative law, and here is associative law. So let's discuss them in detail. The very first is R1 plus R2 is equals to R2 plus R1. This one is there. Second is R1 into R2, which is not equals to R2 into R1. After that, if we talk about associative, so this is R1 plus R2 plus R3, which is equals to R1 plus R2 plus R3. Okay. And R1 into R2 into R3, which is R1 into R2 into R3. R2 into R3, like this. Let's talk about distributive law now. Distributive law. Okay. And here we will discuss identity law. So distributive law is like R1 plus R2 R3, and this is not equals to R1 plus R2 R1 plus R2 R1 plus R3. Okay. This is not at all distributed like this. This is wrong. Which is the correct way? R1 dot R2 plus R3. This is now distributed as R1 dot R2 plus R1 dot R3. So this is valid. This is valid. As we don't have any space for identity here, so let's write them below. Let's write it below. Identity law. Identity law. So identity law is R1 plus phi, okay, is R1. After that, R1 into epsilon is R1. Let's discuss about idempotent law. So this is like R1 plus R1 is equals to R1, and this is valid. Okay, but R1 into R1 is not equals to R1. So this is not at all valid. This is not at all valid. Okay, now let's discuss some standard result for regular expression. So the very first is R star star is R star. Second is epsilon, phi star is epsilon. Third is this plus is equals to phi. Fourth is epsilon star is equals to epsilon. Fifth is epsilon plus is equals to epsilon. Sixth is r plus is equals to r into r star, okay, which is r star into r, we can say that. Seventh is r star is equals to r plus epsilon. Eighth is epsilon plus r is equals to epsilon plus r, which is not equals to r, right? Ninth is r into r is not equals to r. After that, 10th is epsilon plus r into r star, and this is r star. 11th is a plus b star, which is a star plus b whole star, which is equals to a plus b star whole star, which is equals to a star plus b star plus star, which is equals to ab star plus ba star star, which is equals to a plus b star whole star, okay, which is also equals to a star b star plus a star b star and whole star, like this, which is also equals to b star a star star, okay, which is also equals to a star b star and the whole star, like this. And the 12th one is a star phi is always phi. R phi is always phi. These are the results, very very important, and these are standard results for regular expression. Okay everyone, anyone having any doubt? This you should learn actually. So if you see the screen, you should just mark it correct. I hope that there is no doubt till now. Alright, now let's see some important note. So the very first is union of two RL, two regular language, is always a regular language, and union is commutative and associative. Okay. Second is finite union of regular language is always regular language. Okay, so infinite union of regular language may or may not be regular. So infinite union of regular language may or may not be regular language. So the third is infinite or finite intersection of two regular language is always regular, but infinite intersection is not regular, it is non-regular language. It's a non-regular language. Okay. Fourth one is concat of two or more regular language is always regular. Okay. So rest of the point everyone, I hope that there is no doubt in this. So tomorrow also we are going to consider same TOC only, we are going to revise. Okay, whatever the remaining portion is that we are going to revise in tomorrow's class. So we will continue with this. After that, we have to also revise the Mealy and More machine. After that, we will revise the whole TOC grammar. After that, type 3 grammar, type 2 grammar, type 1, type 0, everything we are going to revise. After that, Chomsky normal form. Okay, so removal of left recursion, removal of right recursion, simplification of grammar. After that, whole CFL is left, then whole TOC closure property is left. After that, REC and RE is left. So it will take time. Okay, so definitely it is not going to cover in complete 1 hour. Some few lectures we have to take, and after that we will start with CD. And trust me, if you revise this all, you are confirmed with your 8 to 10 marks. And also we have revised CD, Algo and DSA. From that also 18 to 20 marks are fixed. So if you do this, so 20 plus 10 is 30 marks are fixed. And if you are good with aptitude, so 45 marks, 45 plus you can score just by preparing APT or Algo plus DS and C, TOC, CD. After that, some easy subjects are also there like DM and maths. They also comes up for 10 to 15 marks. So you can see that if you're good with all these subjects, it's very easy to score 50 plus. Okay, everyone? So, yeah. So tomorrow also, we will revise the same. And if you have any doubt in any of the class, please comment it below. I will answer all your doubts and all your queries. If you have general preparation doubt also, you can ask. Okay, so I hope the class was interesting and you got to know all the things and it was helpful for you all. So see you all in the next class, and do let me know if you have any query regarding any of the classes. Okay, everyone. So see you all in the next lecture. Thank you so much, everyone.